Friends, good morning to everyone. We are dealing with many aspects of organic chemistry since many days. Today, we are going to discuss about one of the rearrangements given by Brooks. This rearrangement is named after him as Brook rearrangement. He is Sir Adrian Gibbs Brook, a Canadian chemist, obtained his PhD in organic chemistry from University of Toronto in the year 1950, and his research specialization is in organosilicon chemistry. He has been honored with various awards like Kipping Award, CIC Medal, Killam Memorial Prize, and he was named as a university professor by University of Toronto and was awarded with honorary doctorate of science in the year 2006. He was the recipient of the fellowship in the Chemical Institute of Canada, the Royal Society of Canada. Brooks rearrangement is a rearrangement in which the organosylyl group switches its position with a hydroxyl protein from the carbon to oxygen. The reaction product what we obtain is a silyl ether. A silyl group, alkyl silyl, and an alkyl group over here attached to through oxygen to silyl. It is their silyl ethers. In other words, this is a rearrangement reaction to obtain silyl ethers. Silyl ethers are the group of chemical compounds which contain a silicon atom which is covalently bound with alkoxy group. The reaction is like this. We take the silyl alcohols and treat with a base. The silyl group and the CHOH group is separated by 1 to 3 carbon atoms. When it is treated with the base, these silyl alcohols gets converted into silyl ethers. Various bases starting from the stronger bases like sodium hydride to the diethylamine, the weaker bases can also be used. Various silyl ethers like trimethyl silyl ether, triethyl silyl ether, tertiary butyl dimethyl silyl ether, tertiary butyl diphenyl silyl ether, triisopropyl silyl ether were prepared by using Brook rearrangement. Overall, Brook rearrangement is a method of choice for the preparation of silyl ether. Let us look into the mechanism of the reaction, how this silyl alkyl alcohols gets converted to silyl ethers in the presence of a base. This silyl alkyl alcohols as OH group in the presence of a stronger base or a weaker base like diethylamine This is basic enough to abstract the proton from the OH, and this OH is acidic enough to lose its proton. It abstracts the proton from the oxygen, and the excess electrons are left onto the oxygen to give rise to oxygen anion. The oxygen anion, as it is unstable due to its unimolecularity, it has to maintain its divalency for its stability. That excess electrons it passes on to silicon, and this has to maintain its valency. Thus the bond between the silicon and carbon breaks. The electrons are shifted towards the carbon adjacent to the silyl group. Here the sharing of oxygen anion electrons with silicon and the breaking of silicon carbon bond occurs simultaneously. A transition state in which oxygen and silicon bond is formed partially and carbon and silicon bond is broken partially has been formed, and the complete breakage of the silicon carbon occurs with the gain of electrons into the carbon giving rise to a carbon ion and a covalent bond between the oxygen and silicon. The bond has been broken between the carbon and silicon, and a bond has been formed between the oxygen and silicon. The carbon ion combines with H plus from the Hb. That excess electrons it takes, it shares with the hydrogen, and I'll get corresponding silyl ether with the liberation of the base. Overall, the reaction starts with the abstraction of the proton from the hydroxyl group to give rise to alkoxide anion, and this alkoxide anion act as a nucleophile and undergo nucleophilic attack on the silicon and displaces the methylene group. A transition state is formed between in which the oxygen silicon bond is partially formed and oxygen silicon carbon bond is partially broken, and it gives rise to a silyl ether ultimately. This is all about Brook rearrangement. In the next presentation, let us deal with the other types of reactions which are named after the scientists. Until then, have a nice day. Thank you.